know.
This is Boyd Steven Smith, Haskell hacker of Free Geek, Arkansas. Currently, he's been hacking a little with GHCI to make some shapes for our 3D printer. Currently, this 3D printer, as you can see, is powered by an 12-volt line off an ATX power supply. Those are 3 Pololus into a rat's nest of wires to a Gen 6 board, which is a Sanguino. That heatsink there that's got the nasty, wonderful screw through it and heatsink is actually not in use. Connected up through a little USB to a laptop over here. This is the actual printer. The X, Y, and Z axes are currently functioning, although not level. There's no extruder currently attached, but we have decided to test these axes, and as you can see, there is a pin. We've done a couple of small test prints here, and even gotten some circles out of this. So we're going to run another little test print to see if we can get the accuracy. Currently it's running quite slow. These motors are capable of some high speeds up to 6,000 millimeters a second, although being able to do that while laying down hot plastic is going to be rather difficult. So here comes another circle. And as you can see, that pin's moving rather slowly, but is making a wonderfully circular shape. We're just using a Sharpie attached with a cork. I'll bet after seeing this video you can figure out where those came from. But it is making a perfectly circular shape to print out on some paper on our heated bed. These shapes were all generated using primitives directly in GHCI. There's no real magic here. That was turned into G-code and pasted into the host-based software for this RepRap. You can see there's 2 Z-axis motors, 1 motor on the back for the Y-axis that's belt driven for the heated bed, which will be heated at some point, followed by the long X-axis there, and a Z-axis. We can't actually move that up and down, and at the beginning of the print we went ahead and moved the pin down to make sure it could do it. And here's the quality of the motion of the pin. Currently the Pololus for the X and the Y axis are set to 1/16 of a step. They were pretty much faster. The first circle on the far right, which at this point would be circle number 5 counting from the left, was actually printed in less than a second. Every one subsequently has been printed much slower. I'm sure we'll figure that out soon. In the meantime, happy printing.